Okay, take one. This is Ed Kiebler. I'm with Tony Bischoff and Darren Morgan at BES Racing Engines. This is going to be one of our segments for the EPE show coming up in January. So we just wanted to get these two guys and do a little discussions on head porting and some of the things that you guys do to make cylinder heads, you know, perfect when they go out the door, right? They're perfect. Yes, exactly. So one of the things we did last year after EPE was we kind of talked to some of our viewers and asked them what they wanted to see in an educational video, and it was overwhelmingly skewed toward cylinder head stuff, either surfacing or guides or seats or porting or what have you. So we've got a list of questions here that a bunch of our viewers have turned in, and we're going to ask the two experts here some questions and get their answers. So we'll get started here and we'll get into this. So one of the first things that people ask is on seat rings, what kind of press do you all put in a cast iron head and an aluminum head? So when you're pressing in seat rings, what kind of interference fit do you all want for that?
Well, typically on cast iron, a good round number is 4 to 6 thousandths press. And if you go to aluminum, naturally we want to put 2 or 3 more on. So we go 6 to 10 typically on seat rings.
Okay.
That works pretty good for just about everything.
And it doesn't matter diameter-wise, right? Because we get customers asking, well, smaller diameter, larger diameter.
We use that rule just about everywhere, but you could go a little bit less press on the, say, exhaust seat, but we don't, for the most part, we shoot for them numbers everywhere.
You shoot, okay. All right. And what about when you're cutting for seat rings? There's always been this connotation out there, you know, you'll set up a stress riser where you've cut for the seat ring if you don't use a radius bit or a bit with a chamfer on it.
That is true.
What do you recommend, Darren?
Well, usually you're going to have on most of these cutters a 25 to 35 thousandths radius.
Okay.
And all the seat rings are radiused as well.
Right.
We go to painstaking efforts to make sure that radius is matched or bigger than the radius in the register itself at all times. That's all you really have to do. But yeah, it should have some radius there.
All right.
And yes, it will cause a stress riser. And then like really weak OEM cylinder heads, like let's say a CJ head, an iron. I mean, they don't have a lot of meat underneath there. So any stress riser is going to crack them right out.
Okay.
And also on something like that, that's a case where the press fit itself goes down to like 5, 6, no more than 6. I mean, we try to just get real close to that because, again, the stress in those weak heads can cause stress risers and crack them everywhere.
Crack them everywhere, especially if you get a guy that says, okay, 4 to 6 is good. I'll be safe and I'll go 8 to 10 in a cast iron head. And
yeah, you're playing with fire.
You're playing with fire.
You know, and the big thing you got to remember on factory heads, cast iron heads especially, the castings ain't very thick in the chamber. So some factory heads I won't even put a seat ring in because they crack too easy. So one thing I always try to remember is one, I don't go very big on the seat, so no more than 60 bigger than the valve. And a lot of times I won't put it but 200 deep because again, you go too deep, you get too close to the outside edge of your chamber, and then they bust that way too. So I can't say from a personal standpoint, most old cylinder heads anymore, restoration stuff, I recommend the customer, unless it has to have a seat put in it, I don't put seats in it.
You don't put seats in it.
I tell them to run lead additive because I've had too many unobtainium castings that crack, and then you're done. So,
right.
So on factory stuff, I try not to do seats. There's a few motors I know we can do it, and other ones I know we can't do it. There's a lot of Ford heads that you cannot put them in. So.
Okay, and then you just recommend lead additive.
Lead additive. You can run that once or twice, and then you're good for several thousand miles. And then you say you run it some lead additive every 10 tankfuls or 5 tankfuls or something. And that usually works okay.
Okay. Explain just a little bit for some of our viewers. Maybe they don't understand what the lead actually does.
The lead is lubricity.
Exactly. Yeah.
Yep. That keeps it from wearing out.
So you have two incompatible materials, steel and iron. the harder is always going to wear into the softer material. Well, the iron is much softer than steel. So without any lubricity there, it's just going to eat itself.
It's just going to
literally gall itself into the cylinder.
Into the cylinder head. So that's the reason for the lead in the fuels at one time. We've taken all the lead out now. That's the reason that you have to put a hardened seat in, because the seat ends up being, the hardness of the seat is harder than the actual valve.
Mm-hmm.
And when you can't put seat rings in, then just add lead additive.
Yep.
Okay.
And that works good for restorations that don't get a lot of miles. Now, naturally, if you're going to put a couple 100,000 miles on it, you have to figure out how to put seats in it. But most people don't do that to their 1971 Cleveland or whatever they're
Right.
working on. So.
Right. Right. Another question we had is when you get into what we call endurance motors, in other words, boat motors, okay? These guys that with the twin or triple big blocks in them or what have you, and obviously very hard conditions or very rough conditions on a motor because you're at kind of full power the most of the whole time. Is there any differences when you're preparing a boat motor head or an endurance head? Just from a seat, installing seats or something like that. Is there any difference there? Or
Not really. I mean, you get particular on everything, but I do make sure we run higher grade exhaust valves. Definitely for sure higher temp exhaust valves in Canal, or they call them different stuff these days, but I try to put better exhaust valves in.
Okay. So
especially on the supercharged stuff. So.
And we'll run the seat width out to like 55.
Okay.
Yep.
We're on
seats.
something that has to make some power. You'll run them down to 35,000.
Okay. And explain.
And they're going to get wider.
Yeah, that's right. Yeah, they're not going to get narrower.
It starts off as 30. It comes back as 50. So.
That's right. Explain to maybe some of the engine builders that are just getting into this business, what does seat width, what effect does that have on the valve itself, Darren?
On the valve itself?
Yes. Is it? I mean, you run a wider seat width on an exhaust valve versus an intake.
Its ability to dissipate heat in the combustion chamber
Okay.
goes up considerably, especially on an endurance application, supercharged application, something that's at constant throttle, like we were saying, a boat.
Yep.
Yeah, you need to have the higher grade valves because of the heat dissipation up through the guide and then into the seat area. So you need to give it that area.
So wider seats. If you were using a normal exhaust valve, what would your seat width be typically?
Well, say on a stock motor, sometimes you might make it 80 wide or something like that.
Okay.
The wider it is, the more heat that it'll pull out of your valve.
Dissipates heat better.
The wider it is, the less it flows. So you want to, it depends on how long they're going to run it, stuff like that. Some of these boats, they might only put 200 hours on them, so sometimes still we don't go super wide on them, but it just depends on what the guy's planning on doing with
Okay.
it. So.
All right. That's great information. Let's see. One of the other questions was, is it better to interlock seats in a head or not?
Yes, absolutely.
Interlock the seats.
Yeah. Of course, that's fraught with a lot of problems. One being let's say somebody has interlocked the seats to what we call max. In other words, they're not overlapped where one seat is into the next seat ring over.
Okay.
And this happens quite a bit when you install, the exhaust seat and then cut the intake seat into it, and then you'll see you're actually seating on part of the intake seat has exposed itself. And at that point, that's not proper. You need to put a smaller seat ring in there and get the intersect correct. But a lot of times what will happen is they've gone maxed where any increase in either seat ring is going to cause that problem. And at that point, you kind of have to make a judgment call. But sometimes we'll just have to weld the whole area up.
Really?
Yeah.
Okay. All right.
And some of the problems that he's talking about is created by people, head guys that like to get every bit of flow they can get, which makes power. That's why they do it. But sometimes you sacrifice durability with these big valves, especially in the inline motors, because they're so close. Whereas a canted valve, you can get bigger seats because they separate them. But so when you pick valve sizes, you need to discuss or decide what kind of durability you're looking at. Some drag race motors, it don't make no difference. They're going to freshen them up every 30 runs anyway. But they're wanting to get hundreds of runs or thousands of runs, then you got to run smaller valves so you can get away from that overlap so much.
So it's all about the application.
Absolutely, application.
Okay.
Application specific.
That should be that should be one of your first questions. when a guy comes to you and says,
if you're class racing and somebody's beating your customer, you tell them you're going to get in maintenance where we can make it better. But they have to realize it's going to create problems that, adds to more money and more maintenance.
Sure. Mm-hmm. Okay. All right. How about seat materials? And again, I'm sure that's somewhat application specific also. But talk a little bit about seat materials that you all use in some of your applications.
I don't feel really qualified enough to answer that question, to tell you the truth.
If anybody,
that's really a question for Claude at CHE, because he's the metallurgist.
He's the metallurgist?
He's the mad chemist that gives us all of our seat rings.
Okay.
But on the very basic level, copper versus iron versus hardened powdered metal.
Right.
Each has its individual use in case that you would use that.
Talk a little bit about that, would you, Darren?
Well, let's take, for instance, the powdered metal seats. Mm-hmm. I mean, those are only used in industrial applications. And very, very rarely will you see those in an aftermarket cylinder head. They're almost too hard. Well, they are too hard in many, many cases. Okay. Not always, but in many cases they are. And you also have to have the compatibility with the valve that you're going to be using. You wouldn't use a hardened powdered metal seat with a titanium valve because it'll completely destroy the titanium valve within 30, 40 runs. So we use bronze because, again, we go back to that the compatibility of the two metals, their hardnesses and lubricity. And basically that's what you're matching with all these different seats. But that's something that even I get on the phone, or they get on the phone too, and say, hey, Claude, what's the best seat for this application?
Okay.
And before we were stuck with beryllium alloys.
Right.
In pro stock and comp motors, that's all we had. But the metals today, I mean, some of the phosphorus bronze alloys he uses are far better than even those were.
Okay. All right. And you mentioned a little bit about titanium valves, and we're going to digress just a little bit because we'll get into some valve questions. But we talk about titanium, and it'll wear the titanium out. Are all titanium valves now coated, like DLC coated? No.
You have to request that.
Okay. All right. Do you all recommend that in a titanium valve?
It's situation dependent.
It's like you said, on power outer stuff that you're going to eat a lot of stuff up, burn pistons. We never get them coated because it's very expensive, and when you have to grind a valve, you grind it off.
Right. So
endurance applications, there's no doubt the coated valve, the seats hold up better, the valves hold up better. They're almost phenomenal. So naturally aspirated combinations, that's not going to get a lot of valve jobs, and you want the seat to wear very well. I like the coating, but it is pretty pricey. But power outer stuff, I don't ever coat.
What is it now? $50 a valve?
Last time to do ATEM is like $300. So yeah.
Okay.
Probably a little bit more now. And that's constantly
And by
changing.
the way, titanium's compatible with nothing. No other metal. It's going to wear.
It's going to wear.
Yeah.
Yep.
And that's why you see all the NASCAR guys, they were the ones that got into the beryllium alloys and all those different copper, beryllium, aluminum, phosphorus, bronze alloys, trying to figure out a way to make those valves live a full race. Okay. So we owe all this stuff to
the Cup guys?
Yeah.
Well, that's a good attaboy for the Cup guys. So we're talking a little bit now. We've got some questions on actual valve jobs. So it says, when cutting seats with a form tool, do you need to lap valves and seats afterwards? So
the answer to the question is, if you need to lap it afterwards, you didn't cut it right to begin with.
Okay.
So no, that you shouldn't have to lap a valve.
All right.
But people will go to extremes to try to hit some predefined concentricity and out of round. I mean, you can get away with 1.5. That's okay, and it's going to seat just fine. But nowadays, there's machines that we can get them down to 2/3.
Right.
But you can achieve, what I'm trying to get at is you can achieve good results on just about any machine. It's the time factor. How long does it take to achieve that result?
Okay.
So you just have to take your time. And also, it's not uncommon, and actually it's standard practice for me to do 2 valve jobs. And sometimes I'll have to do 3. because what I'll do is I'll rough them out to 5/1000ths high and then blend them in to get rid of a lot of the material that form cutter is cutting.
Okay.
Because if you're cutting too much material and your seat's not quite concentric, in other words, the back wall has more material, it'll try to push off of that area,
Sure.
and it destroys the concentration.
Path of least resistance.
But if I can blend it all in and come back in and just touch it, it's right there.
Right there.
Yeah.
Okay. And you brought up a good point. You know, you get these guys, I know as an equipment manufacturer, we always tell customers 1/1000ths per inch is what?
Spec.
Yeah,
Yeah.
is spec. And are you comfortable with that? Are you comfortable with 1/1000ths
Anything
per
over
inch?
1, and I'm cringing.
You're cringing?
Yeah.
Okay. All right. So on a 2400, 2600 intake valve, you
If it was
want
one
to
and
see
a half, I would be.
you would be okay with
I would
that,
be okay with it.
but not happy.
no,
Okay. All right. So 1/1000ths or less is what you're really looking
that's
for.
what you're always shooting for.
Okay. All right. Well,
That's
that makes
the target.
perfect sense. Yeah.
And some heads,
Hard to do.
it's hard to do.
Let's see. So I guess to recap just a little bit, no need to lap valves. If you're lapping valves, all you're doing is really covering up poor machining.
Usually when I lap valves, I lap it to just the exhaust to see the seat because I have to blend up to it.
Okay.
That's my really only use for lapping valves.
So it's just to see where the seat's at.
Yeah.
All right.
And we vacuum check every single hole.
Sure.
So, I mean, you put that valve on there and you hit the vacuum, it should seal.
Right.
And if it doesn't, it's off.
Yep.
It's just that simple.
Something else you have to remember: on a coated valve, you lap it one time, you just throw
Oh, yeah.
$50 away.
You ruined
You
it,
just
didn't
ruined
you?
the valve.
Yeah.
It will take it right off, even though it'll run forever in the engine. You hit it with lapping compound, it's junk.
Yep.
Not junk, just there's no
Yeah.
coating on it.
Yeah. Okay. All right. Let's see. Back cutting valves. Do you back cut both the intake and exhaust, or just one, or the other?
The exhaust is really not. It's just, we've done it back and forth. Have you ever seen a difference back cutting exhaust?
Well, I've seen it on the flow bench. You'll see how much it changes where it flows better. You might back cut it and pick up flow at 300 and lose at 400 or something. It typically doesn't make a huge difference, but I mean, it's just what you play with on the flow bench, really. So.
And on the intake, it's mandatory.
It's mandatory.
Yeah.
Okay.
And the width and the angles that you use are situation dependent.
Okay.
It's
Well, those are
engine
some of the other
specific.
questions. So elaborate a little bit on those, because those are questions on the list here.
All you're trying to do with the back cuts is tune up the venturi section underneath the throat.
Okay.
Okay, so if you have an engine, a high-end engine's got to turn 10, 11,000, you're pushing your throats out really, really big, and now you want as much back cut on the valve as you can. You want them wider. Now the problem is you made your valve too wide or too heavy, so now you got to shrink those up. So you're constantly working with this size, area, weight relationship all the time in every single case. But basically what you want, and I always say the easiest 10 horsepower anybody will ever gain, is just take a Manley 202 intake valve out of the box and back cut it equal width. 30 degrees back cut, 45 degree seat. And we did the test multiple times. It's always 8 to 10 horsepower.
No
it's just
kidding.
That simple.
Just
That's
by
how
back
powerful it
cutting.
is. And what you're doing is you're tuning the flow curve up, down low. When the valve is close to the seat, all those back cuts form a venturi. If you don't have that, it's just a sharp ridge.
Okay.
And you'll see it immediately.
All right. Yeah, that makes perfect sense. So 8
And
to 10 horsepower on a just kind of a stock motor with a 202 Manley valve in there. There's a 8 to 10 horsepower recommendation right there. So, and you cut it. I think I heard you say you cut it the same width as the intake, the seat itself.
For a 45 degree seat. Yeah.
So if you have a
So
60
if it's
thousandths wide,
150 wide, make it shrink it up to where they're both the same width, whatever
okay,
that is.
whatever that is.
Yeah.
Okay.
And on 55 degree seats or 60 degree seats, we have three angles, three back cut angles.
3 back cut angles.
Yeah.
Okay. All right.
Because you're turning the air off of a 12 degree surface, you're trying to cut it 15 degrees
Okay.
at a time.
At a time.
Yeah.
That's the most.
That's what you're trying to do.
Okay.
So you could mess with this angle and this angle and try to cut it 15 degrees at a time. That's basically what we're doing.
Okay. All right. And that brings up a point. when do you run? You know, we've all used to the 45-degree seats, and then we went to 50-degree, and then you hear some 55s, and I heard you mention 60-degree intake seats. When, and I'm sure it's application specific,
Very.
but just kind of give an overview of when you would look at you know, steeper seat angles.
General rule of thumb: the steeper the seat gets, the increase in wear of your valve goes, and seats go way up quickly. So steeper seats are not used in anything else but drag racing,
Okay.
or maybe truck and tractor pulling. We don't even like to go really steep on those. But like unlimited comp stuff, yeah, they got 60-degree exhaust seats. Some of them have 58-degree intakes. But you know that you're going to freshen that engine up after 10 runs.
Okay.
So it's not a big deal. And that's about all they last.
All right. And you can get, and I hear people, well, you can't go too far because the valve sticks.
Yeah.
Yeah, and you guys, I'm sure, being in the business that you're in, you have pushed those limits and figured out where they were at.
Yes.
So,
Something I'd like to add to the seat deal to overly simplify it. There's two ways you got to look at it. The steeper the valve job, typically speaking, the more it helps at higher lifts, and it hurts your flow at lower lifts. Naturally, the seat width changes that too. So I always say, as a rule of thumb, if you ain't over 750 lift, there's no reason to go to 55.
okay.
But I would reiterate on something different after this, but and say 55-degree seat, you need to go over 900 lift, or even like a 60-degree seat. But on the Engine Masters, we learned we ran a 60-degree seat on our Engine Masters challenge, because, and it kind of wide, because that made that 0 to 100 lift, it was almost shut off. Now you run a different camshaft because we didn't want it to flow there.
Right.
Does that make sense? Does that make
Sure.
any sense to
Sure.
you? So we picked up a lot of low-end power by running a steeper seat. But we still had this high lift flow, so it made us a really broad torque curve. So that is a low endurance application, because it didn't last very long. But my point is where you want your cylinder head to flow at, that changes that a little bit, and so that is application specific. But so it doesn't, that lift to steep valve angle rule doesn't apply to everything because of what I'm talking about
Okay.
there.
All right. You know, one of the things that I just keep hearing over and over and over is and I'll put myself way back, 40 some odd years ago. You're building your first street motor, or you want to go a little faster. The first thing you do is you put headers on it, and then you put a I'm really dating myself, a Holly carburetor on it,
They still
and
make
then an aluminum intake manifold, and then you start getting into camshaft and cylinder heads and different things like that, and you start looking at magazines or getting on the internet or what have you, and this guy recommends these cylinder heads, and this guy recommends these pistons, and this guy recommends these valves, and you start buying this stuff thinking you're buying the best, when in reality it's probably furthest from the truth, because you're not buying what the application calls for. So you could have the best lower end motor on the street, but your cylinder heads suck, so you're not going anywhere.
Well, I mean, naturally you got to have the right combination
Right,
of parts.
but I mean, that's what I hear from you guys is it's so important to start at the ground level and ask all of these questions before you start investing money.
Where you want to make your power, how you want it to idle, that's the most important part. Getting the right cam for your RPM, right converter, right gear ratio, right intake manifold. It all needs, the difference in having a mediocre engine and a real good engine is critical to get the right parts.
The right combination.
And there's some false economy with that too. And a lot of people will think that they can buy an engine that makes lesser power for a lot less and then step it up later. And that doesn't work.
Doesn't work, does
it
it?
ends up costing more than if you just would have invested the money in the first place.
Way more.
Yep.
Way more.
Yeah.
Because you're throwing something that was good but not right away to just redo it all. Just decide what you want, and then have somebody that knows how to put the right parts together.
Yeah, it'd be like buying an engine block with a cast crank in it, because you're only going to make 400 horsepower, and then you put a set of heads and a cam and everything else on it.
Sells you a nitrous kit.
Yeah, and a nitrous kit, and suddenly, well, this crank's no good, the rods are no good, the pistons are no good. I got to start. And the block's no good,
Yeah,
by the
block's
way.
not strong
You know,
enough,
so yeah, it's okay. That makes perfect sense. Let's see if we can pick up here. You prefer thick seats for intake. When do you run some of the higher seat angles? We kind of talked about that. It said, do you run higher seat angles only on intake seats, which you guys have answered
He
that.
hit it on the head. It's proportional to lift more than anything
It's
else.
more about lift. Okay. All right. We get into a little bit of guide work now. It says guide clearances between valve, stem, and guide. What is there? A naturally aspirated motor versus a power adder motor. They're different, and just as a rule of thumb, what do you guys look for as far as?
And this also it depends on some factors, like how much guide's sticking out into the exhaust stream,
Okay.
and how small how high is the gas speed over that guide, and the thickness of the stem, whether it's 5/16. So for a power adder application, you would run probably another thousandths more clearance on the exhaust guides.
That's a good rule of thumb. So
and if it goes from 5/16, maybe 1.2 bigger.
Okay.
More, just to give it enough room, the heat expansion and the heat alone is going to burn you all out of the tip of that guide.
okay. Well,
So
yeah.
you just have to give it more room to get some lubricity.
How about guide materials? The old cast iron guides versus the powdered metal guides versus the bronze guides.
They all have different specs.
Right. Yeah, because the expansion,
And whether you're using a stainless or a hollow stem steel or a titanium valve, the specs change with that too.
Depending what coating's on them. That's a pretty tough one.
And coatings.
To overly simplify
that's
it.
hard to give you a specific answer on
It
something
is.
like that.
But to overly simplify it, if you got a bunch of spring pressure with a big cam, I always like bronze guides because they're much less likely to stick. Does
Okay.
that make sense?
Yep.
Where a cast iron guide is more prone for galding. But I find it, for the most part, in a street application with somebody wants to put some serious miles on it, the cast guides will always outlast the bronze.
The bronze guides.
They do last longer, so I like them in street applications, unless they're going to run some kind of ridiculously big camshaft with a lot of spring pressure. So, and as far as clearances, I think you always looser on power adders, but for a good rule of thumb, this is a little, I think, on the loose side, but a thou and a half on the intakes. 1.5 to 2 on the exhaust, and then if it's a power adder, you're going to go 2.5 maybe.
Okay.
That's kind of just a rule of thumb. So.
All right. We're speaking about guides. What about guide finish? How critical is the finish of the guide?
It gets more critical as the endurance of the engine goes up. So
Okay.
for endurance application, I mean, those guys in the NASCAR world, they'll sit there with a diamond honed
Right.
and get those things to within 1/10 total taper, bell mouth, and the surface finish is. The last I heard, he was using a profilometer on the dang thing.
Wow.
So it's very important because they have to last 2 races with those things,
Yep.
and maybe 3
So
in practice.
So they're actually doing surface analysis of guides now.
And we have to put up with a lot of heat really fast. So our surface is going to be, it's not as critical as something like that.
Right.
The clearances is 100 times more critical than the surface finish.
Okay. All right.
Just a decent crosshatch with a 320 is more than enough.
Okay.
And the metal of the guide, what type of bronze alloy it is. And even there's guides out, we make guides out of beryllium. And they never wore. They were absolutely awesome, just too expensive at $250 a piece.
Wow.
And Claude has a seat or a guide material called Tough Net, which is a nickel bronze,
Okay.
and it's indestructible. You can literally stick it out 2 inches into the airstream, and it doesn't phase it.
And it doesn't. You don't get the.
But machining them, it's going to take you all day to hone them.
It'll take you all day to hone them.
Yeah.
That brings up another point: is from a machining standpoint, a customer or one of our guys asked, reaming or honing?
Both.
Both. There's a place for both.
And for some applications, and when you have production line, just ream them.
Right.
They just ream them.
We do struggle with that on bronze guides. I prefer to ream it because it's way faster. But you go through a lot of reamers, which are very expensive, and they wear and they get tight. So, like he says, we typically ream them, and then we finish them to size with the hone.
With the hone.
Hopefully it's a few strokes, but sometimes we got to take a thou or two out. But
This isn't the old days. We got precision carbide,
Right.
fluted.
Oh yeah.
That really cut. But as they wear, sometimes they'll put a little more a little taper at the tip that you got to hone out.
You gotta
or something
hone
like
out.
that.
Okay. All right. Let's see. Should you use sealants Loctite when installing seats and guides in cast or aluminum heads?
I would say no. You shouldn't have to.
we don't.
Right.
We try to make sure there's no leaks before we put them in. So,
Right.
we do usually lube them to put them in because to keep them from scalding the material when we put them in. We
Yep.
usually heat the head. So on aluminum, we heat the heads and then press them in that way.
That was going to be my next question is on aluminum head, it's pretty critical that you don't roll the material as you're installing the
Oh,
guide
Yeah.
because that creates all
We
kinds
go
of
in
issues.
and make sure to deburr all that area and make sure the radius on the seat is sufficient to where when you put that in there and we have the stabilizer that will hold it in place.
Yep.
And that head is stabilized at 230, 240 degrees. So it doesn't take a lot to put them in.
Okay.
It shouldn't
Right.
take a lot.
Right. Now, do you freeze your guides or your seats? No, you just heat the cylinder head up, and typically only on aluminum.
Yeah, they don't heat. You never heat the cast iron heads, do you?
Yeah, I didn't know. I've never seen it, but I thought maybe.
Yeah, no, we've never done that. So, but we do heat all aluminum.
All
heads.
aluminum, and you use a lubricant on the
We
seat
just use motor
or the
oil.
guide.
Or maybe just use motor oil, right?
Yeah.
Yeah.
You can use any press lube.
Okay. But the key is don't roll that material.
Yep.
Yes.
The key is making sure your seats got a nice radius on it,
Yep.
and your
And
finishing
your tooling
bores.
isn't
Yeah.
sloppy.
Okay.
It's got to be
Rigid.
registered. Yeah, rigid.
Okay.
Yep.
All right. Let's see. And now we're going to get into a little bit. We wanted to get into some porting discussions. Now, we're sitting behind a brand new 5-axis porting machine that Mr. Bischoff was kind enough to purchase from us. But we want to talk about basics. Are you out of... Oh, there we go. Well, we want to talk a little bit about basics because not everybody is going to spend this kind of money to port cylinder heads or do blocks. Mm-hmm. So some of the questions that the fellas had is how do you choose a grinder to start with? I know that's a very basic question.
And it is a personal preference.
Okay.
I mean, some guys like the old Milwaukees that weigh 10 pounds.
Right.
And I've never been able to do fine work, but I have managed to actually persuade many of the people in the industry to switch to Dotco grinders.
Okay.
Because, yeah, they're $1,000 a piece. They're $1,800 for the big ones that I use. And you got to remember, I use a 3/8 shank with a 1-inch diameter burr that long with 8 flutes on it,
Holy
spinning
cow.
28,000 RPM. Well, I can walk into a wall and take a 1/4 inch out with that thing.
Wow.
And if it got away from you, it hurt you.
Yeah.
But if the Milwaukee's got away from you, it could kill you. I mean,
Okay.
I have been knocked to the floor with those things, and it was that. So I started looking for different grinders, and the Dotcos are the most bulletproof. I've had the 2 in there are 22 years old.
Wow.
And yeah, they're $1,000.
And
you just replace the bearings and the blades every 2-3 years, and you're off and running.
and you're off and running. And I suspect you've put quite a few hours on those 2 grinders, Darren, for your career.
I can't even imagine.
So, when you talk about those, is it the feel of the grinder? Is it just
It's
the
the
quality of the
dexterity.
grinder? It's the dex. Okay.
Yeah.
Yeah.
Being able to manipulate it in any way and still have that torque.
Okay. Versus that big old bulky.
Yeah,
kinda
you have
over the
all
shoulder.
the torque and no RPM with those things.
Okay.
These things are 25, 28,000, and you need real high speed because you want the burr to do the work for you.
Right.
You don't want to sit there breaking a sweat on the thing. Just let the burr take the material out for you.
Okay. All right. Great
But
information.
the good thing about the Dotcos is if you want torque, it's there. You
It's
can
there.
walk into something and it will.
Remove some material.
Yeah.
Okay. All right. there was another question on how do you choose a lollipop cutter length, shank size, lollipop diameter, cast iron, aluminum. Well, obviously, there's different flutes for cast iron and different flutes for aluminum. We all know that.
You need to see my burr collection. I've got about $6 grand worth of burrs sitting there.
Really?
Yeah, all different shapes. If I have to grind a shape, I want the cutter to have the shape.
Okay.
If I want a certain bowl arc, I want that to already be close within that cutter, not try to actually shape it.
Okay.
But
All right.
that helps immensely.
So if you were trying to put a, you know, and I know nothing about this, but if you were trying to put a 3/8 radius in a intake port, you wouldn't be using a 1/4 inch tool trying to create that. You would be using a 3/8
reverse tapered cutters. You know, instead of a cutter shaped like this, mine are shaped with a T, so I can reach around the corner a bit.
Okay.
So when you, especially like a Pontiac exhaust port that comes out like this,
right?
I mean, there's almost no way to reach it, and when you're contouring short sides of those little radiuses or whatever, you have to have the proper shaped burr to actually get in there. Otherwise, you'll be forever.
Okay. All right. All right.
I mean, there are a couple of companies out there. There's Circle File, there's SF Carbide, and both of those companies make and have made all my cutters.
All your cutters.
Yeah.
How about once you're finished with a cutter? Obviously, I assume you use sand rolls. What grit size, roughness, that sort of thing? That's another question that the guys I ask constantly.
It depends on the application, but if you just go 60 grit all the time, you're never gonna
you
mess
won't go
anything
wrong.
up. Yeah.
Okay. All right. Well, there you heard it here. 60 grit, and you're good to go. How do you actually hold a grinder to prevent the thing from running away with you? And we kind of laughed and talked about this earlier. Some of Darren's skills and what he can do with a grinder, but
It's practice.
it's just practice.
Yeah. I like to have the hose behind me, and I like to have it right here, and I pull my arm up like this, and I brace.
Brace.
Yeah.
Brace.
If it gets away from me, I don't want any slack, because if there's slack, it comes back and hits you.
Whacks you.
Yeah.
He's probably all the time he's got some part of his body up against the manifold, like his forearm or something. So he's braced with the part he's doing. And like he said, practice. You got to have strong hands. It's going to be a little bit harder for somebody that's never done it. But I bet if you checked his grip,
After 25 years,
could crush
Yeah.
You're
Yeah.
not-
Yeah.
You'd never guess it, but I guarantee you, he could crush you.
Yep. Yep. It's like you need that almost like a 3 legs. You got to have the 3 areas of support there to keep the thing
Yeah.
under control.
Yep.
Okay.
And you'll subconsciously learn that, you know.
Right. After it
The
gets
hard
away
When
from
he
you.
goes
Yeah,
to
the
grind
hard
it,
way.
once he goes to grind it, he ain't thinking where he's putting it. He just
He
goes
just
there.
does it.
Yeah.
Yeah. It's just comes
He'll make
natural
it
now.
He'll make it
after-
look easy, and it's not. It
Right.
ain't even. You know,
No.
you give a novice one of them things, and it ends up bad.
I just try to grind a hole I drilled that wasn't big enough, and I try to grind it out, and I end up going, you know. So I know exactly. Believe me, I'm in awe of your ability. Let's see. How do you? Great question here. How do you go about laying out an intake track? And what are, if you were to look at, what are the 3 most critical things when you start, when you're starting out?
It's kind of a little loop there, because it's like, how much power do you want, and can the head support it? And then we're going to tune the intake to what we can get.
Okay.
You know, so guy comes in and he says, I want to make 1,000 horsepower. Well, you only have a 250 valve or a 200 valve. You're not going to get there with that cam. So what we're going to do is we're going to say, okay, start at the valve. The valve is a limiting factor. How much air can that thing support? And then that will govern the RPM range of the engine. And once we know where that thing's going to run, then I can say you need this long a runner to fit with that cam and that RPM range.
Okay. All right.
It's the basic steps.
That's the basic steps. All right.
And to add on to what he's saying, sometimes you have an engine that you're starting with that you can't tune the runner length or taper. So the 2 things establish power band, RPM range, is runner length and cam duration. So when you, typically speaking, if you have too short of an intake runner, you got to have a shorter camshaft. Even how you time it changes a little bit. So again, talking about tuning and runner length, some of it's relative to your constraints of what you got. You can only put so long in some applications. You only get certain intake manifolds. So you got to look at the whole cam and the intake together. Is my point.
Okay. All right.
Sometimes we get to pick our battles. Otherwise, we have other ones we just have to fight them as they are.
You just have to fight them as you are. Yeah.
Most of what we deal with, we fight them as we are.
How about the exhaust track? Is it pretty much the same, or is there?
No.
Okay.
It's not. Because the exhaust side is, I hate to say easy, but it is kind of easy. You know, all the heat energy and pressure energy is over there.
Okay.
So you can cam an exhaust port that's kind of crappy, you know, it doesn't flow quite as much with cam timing and duration and stuff. You can make up for those little faults. On the intake side, you can't. It's either right or it's not.
Okay. Intake side's much more critical to the.
Yeah, about 20 times more critical.
Okay. All right.
Much simpler for sure.
Much simpler. All right. That's really all of the questions that we have. I want to thank Tony Bischoff and I want to thank Darren Morgan for taking time out of their busy schedule to answer some of these questions for our EPE group, and hopefully we'll see both of you guys there in Piney Flats, Tennessee in January, we hope again. We always love to have you. It's a great time. We sure enjoy being able to pick your brains and gain some knowledge. So thank you, everyone, and we'll carry on later.
What a day, what a day, what a day. My brain is swollen. I've learned so much today. They told us, don't start cars. We are not going to listen.